Good day, my good students. This is Dr. Eddie Morgan over at Clovis East High School. We're going to look at our homework this week, our lesson 2.1 on finding the slope of a line. We're actually going to find the slope of a line two ways today. We're going to find the slope of a line by looking at a graph, and then we're going to find the slope of a line if we're just given the coordinates of 2 points. So let's get started. Before we start talking about the slope of a line on a graph, I want to remind you of where we've used the concept of slope before, and we called it then the rate of change. We often had tables, with X table and Y table, and we would talk about the change in the dependent variable compared to the change in the independent. And we would call that, we would take two different Y's and subtract them in two different X's. Notice that this symbol here, the symbol that's called the delta symbol. It's the Greek letter D, and we read that as delta X or delta Y. That's something you'll use a lot more when you come in and start going all the way up to calculus. But the delta simply means the difference. In this case, if we have 2 points, the difference between my Y coordinates and the difference between my X coordinates. And we use that in tables to find the rate of change. And we'll also see it's applicable to our slope here. So let's go on. When we're looking at slope on a graph, we're looking at something visual. In that sense, we use the word M for slope, the letter M. I sometimes think of a mountain because mountains have slopes. We're going up slopes or down slopes. Again, there's that symbol, delta Y over delta X. But now we're thinking in terms of an actual visual. We call that the vertical change over the horizontal change. Remember, the Y variable goes up and down on your graph. The X variable goes left and right. And sometimes we refer to that as the rise over the run. Just means when you get up to run in the morning, you wait till the sun comes up. When the sun rises, then you go out for a run. So let's begin with finding the slope using a graph. To find the slope, we want to find the ratio of the rise, that's the change in the Y coordinates, to the run, which is a change in the X coordinates. On a graph, this can be done easily by drawing a slope triangle between 2 points. So my slope is my rise over my run. So notice I've drawn a little slope triangle between two clear points here, where they cross the crosshairs here. And then I just have to count boxes. How much does it go up? How much does it go down? Now notice we usually read from left to right. So I'm going to read up or down. So my down part, you see my rise is actually a -5 because it goes down. And then my run to the right is 3. So my slope is simply the rise over the run, the ratio of the rise to the run, which is -5 over 3. So I can write that as simply the slope is -5/3. That's my slope. By the way, notice that when the graph is going down from left to right, and we always read the graph from left to right, that's called a negative slope. So the slope of this line is -5/3. So let's go on and work the first problem in your worksheet. So once again, to find the slope, we're looking for the rise over the run. Again, I'm going to draw a little slope triangle so I can see clearly. You want to draw the slope triangle between 2 points where the point literally crosses the crosshair on the graph, so you're not estimating. So if I put that in my slope triangle in here, now I'm looking, I'm saying, well, how much is it going up? That's my rise. So my rise is, it goes up 1, 2, 3, 4 boxes. And then what's the run? How many does it go to the right? It goes over 2. So my slope over this time, rise over run, is 4 over 2. Or I can reduce that down to 2 over 1 or simply 2. All right. So the slope of our line is 2 over 1 or 2. We sometimes keep it in the form 2 over 1 if you're ever using it where you're going to graph something and they say the slope is 2, you have to remember that means go up 2 and over 1. All right, so the next problems you're going to work on your own, and I may try to give you a little hint here. Notice in the first problem, we've already given you the points, so you don't actually pick other points. In this case, then, you could come up here and you could draw a slope triangle from here to here. Or, to be honest, you could draw another one. I could draw from here to here. I could even draw another one here. I could draw from, let's see if I can find my point again here, from here down to here, a bigger one. Might be interesting to try to do it all of those. One thing you should discover is no matter which 2 points you pick, the slope will be the same. Again, you want to draw your slope triangle here. So if I pick one point here, I can go from this point over to this point and use that as my rise and my run. Don't forget, over here it's going down, so I'm going to have a negative slope. As you work this problem and you set up your ratio, the fraction, remember the hint I have down below. Only Chuck Norris can divide by 0. I can't, and you can't. This problem is a little bit like the problem number 4, but very different in that the 0 is not in the denominator, which is undefined. It's in the numerator. And so we actually do have a slope on this one. This next slide just kind of gives a summary of the different kinds of slopes. You notice on the first one, we have a line going upward when we read from left to right. And when you have it going upward, that's a positive slope. On the other hand, if it's going downward from left to right, you see that ends up with a negative slope. Remember, when you're counting the squares on your slope triangle, on the positive side, you're counting up, so that's plus, up plus and then over. On the negative, you'll be counting down. Make sure you put down the negative number. We did look at the two unusual ones. If this line's going straight up and down a vertical line, notice what happens, that if you're picking 2 points there, you can get a value up, but your x term, the denominator, is 0. And 3 divided by 0, as we saw, you cannot divide by 0 unless you're Chuck Norris. So in this case, that's undefined. Some students make the mistake when they come to the next one of thinking undefined too, but notice here, when I have a horizontal, the 0 is my numerator, and 0 divided by 3 is simply 0. So a horizontal one is a 0 slope, but a vertical one is undefined. And you can see that in our next slide if you have a chance to want to stop it and see the Slope Dude guide. So if you want a little fun, you can look at this website, www.gdogenterprises.com, and you can watch the Slope Dude, and he'll describe just in a funny way positive, negative slope, 0, and undefined. The second part of our lesson, we want to be able to find a slope given 2 points. In other words, we don't have a graph. And so when we do that, the rise or the run can also be defined as finding the rise is the difference between the two y coordinates divided by the run, which is the difference between the two x coordinates. Notice even though I put y2 minus y1, I could have put y1 minus y2 as well, as long as I also put x1 minus x2. Just have to subtract it in the same direction. So these are my 2 points. You notice them on my graph here. A is x1, y1, and B is x2, y2. And if you look carefully, if we were doing this graphically, you can see that, oh, on the y2 minus y1, there's 3 squares. Well, if you notice, if you were to subtract the y2 minus the y1, that would be 3. Likewise, the x2, x minus 1 actually gives you the number of squares. In this case, it's 4. So in this case, a shortcut, by the way, of writing, instead of writing y2 minus y1 over x2 minus x1, this is where the delta y, delta x helps out a lot. Now make sure you understand one other thing. x2 is not x squared. When you see in algebra a subscript, in other words, a little number below at the bottom of the letter, that just is pointing out that this is the x coordinate of point 2. So my x1, x2, y2, x2 means it's the x coordinate of that coordinate. X squared, you remember, that means when I take x and square it, in other words, that's x times x. So it's 2 different things. If the 2 is up above, it's a squaring, it's an exponent. If it's down below, it's telling you something, it's pointing out a particular point. All right, so let's take a look at this and see how to use this, the 2 points to find the slope. So remember that the slope is the change in y over the change in x. So what I do, I often will remember what these are up here, x1, y1, x2, y2. I hope after a couple times you don't have to write that again. But if I'm looking for y2 minus y1, first thing I do is I just draw little brackets here. And I'm going to start with y2, so I'm going to go 10 minus 6. And then for my x2 minus x1, put another little bracket here, and I go 5 minus 3. And so now we simplify. 10 minus 6 is 4, 5 minus 3 is 2, 4 divided by 2 is 2 over 1, or 2. Now students ask me, well, what happens if I do it the other direction? Well, let's see. I'm going to use the same thing here, x1, y1, x2, y2, but this time I'm going to subtract the other direction. So when I go here, I'm going to subtract, instead of 10 minus 6, I'm going to do 6 minus 10. See how I reversed it? Likewise, I do the same for the x and go 3 minus 5 and see what I get. Now I get negative 4 over negative 2. Negative divided by negative is positive, so I get exactly the same answer. So notice it doesn't matter which direction you subtract the points, as long as you do the same direction for both the x and the y. If you went y2 minus y1 on top and then you switched and went x1 minus x2 on the bottom, you would end up with the opposite of the answer. So just be careful of that. So we look at problem 7. Again, remember we're doing the change in y over the change in x. Remember that we could label one point as x1, y1, the other point is x2, y2. You don't always have to write that down, but just remember you have two different points. And then remember we're subtracting the y's, and then we're subtracting the x's. So go ahead. Just a couple of hints on problem 8. Notice you're going to have, there's a negative number. So when I go to subtract the x's, I'm going to end up with a 2 subtract a minus 1. Don't forget that subtraction is the same as adding the opposite. So 2 minus minus 1 simply becomes 2 plus 1, or 3. On the other hand, in problem 9, the negative is on the y2. So when I have negative 1 minus 1, I'm simply taking negative 1 and adding negative 1 again, so that I end up with negative 2. On this one, problem 10, like last problem, problem 8, you're taking on the y's 2 minus a minus 3. So minus a minus becomes plus 3. On the other side, 11, just try to do your best. Keep track of your negatives. And again, notice you're on both times you're subtracting a negative, which is going to end up being a positive. So let's do a quick review. We've learned two ways to find the slope of a line on a graph. One way we can do is by drawing the slope triangle and finding the ratio of the rise to the run. The other is by determining the change in y and the change in x using the coordinates of the 2 points. So for example, on this graph at the right, if I'm trying to find the slope of a graph, it's the rise over the run. So let me draw a slope triangle someplace, and then I notice how far up does it go. The rise is 3 over 2, so my slope is 3 over 2. Now on the other hand, if I did the points, and notice I've picked the same 2 points we did the slope triangle with, minus 1, 1 for A and 1, 2. In this case, I'm going to change the y2 minus y1. So we subtract 2 minus minus 1, and then the x, 1 minus minus 1. And now remembering that 2 minus a minus is plus, I get 2 plus 1 over 1 plus 1. I get 3 over 2. Notice I get the same slope whether I do it with the points or whether I do it with the slope triangle. We're just one way you're doing it visually, the other way you're doing it algebraically. All right, great lesson, guys.